Hello guys, just confirm that if I am audible and everything is clear. Okay, there is an echo. Okay, is it now as well? Like, is it okay now? Hello, is the voice clear? Is the echo problem clear now? Just confirm once. Is the voice clear, guys? Yes, great. Okay, so let's start. So this class can be treated as a demo class for our competitive programming course at TLE level 2. So if it suits your way of learning, then you can definitely choose to join TLE. So let's start. Let me share my screen. Okay. Just confirm, is my screen visible? Is it visible? Yes, great. Okay, so let's start with today's topic of discussion, that is bit manipulation, which is one of the most important topic from competitive programming point of concern or point of view, or when you think of some online assessment point of view. So bit manipulation is one such topic which is very important, but at the same time there are students who feel this topic as being a bit tough in comparison to other topics. But what we are going to learn today is the introduction part or the basic part of bit manipulation, which will definitely help you out to clear all your that fear of bit manipulation, and you can at least go and attempt the questions of bit manipulation. So let's start. So today we will first of all understand what actually do we mean by bit manipulation and what are the basic operators. Then we will learn some tips for bit manipulation. Then we will see some common patterns in bit manipulation problems. Okay. So the first question is that where is bit manipulation used? That's the first question that comes to every one of us mind, right? That where is actually bit manipulation used? So see, many of you would have seen the problems that directly involve using a bit manipulation, right? Like they would have given you that you are doing the OR of two numbers, and you are doing some AND operation, you're doing some XOR operation, you are doing some left shift, you are doing some right shift, something like this. Many of you would have seen that, right? So that problems are directly involved or directly related with bit manipulation, right? But there are problems that may not directly be visible, that okay, they require some bit manipulation right over here. There are problems. So it is important to understand the entire concept behind bit manipulation to attempt all those problems. So many of you would have seen some problems involves powers of 2, right? So from there it comes to our mind, okay, it is involving power of 2. So it is something related to bit manipulation, right? It is involving powers of 2. So yeah, there is something behind that. So how to approach bit manipulation problem? That's the first thing that comes to our mind. We are looking to our problem. Okay, this is a bit manipulation problem. We have to solve this. We know something and something, some operators and all. But how to actually approach this? So just tell me one thing. If I give you a simple problem, if I give you this problem, just a minute. Yeah. If I give you, let's suppose this problem, 25 plus 32. If I, let's suppose, give you this problem, what do you do? What do you actually do when I give you this problem? So you will first of all see, okay, we will go to the last place, that is ones place in this representation. I will add this 5 and 2 and I will write 7, right? Similarly, I will add this 2 and 3 and I will add this 5. So how did you approach this problem? You just went from left to right, or basically from right to left. You observed what the number is in its representation, that is base 10 representation as we say. You took those numbers and you added the result. This is what you actually do when you approach the problems that involves numbers of base 10, right? But when we are talking of bit manipulation, the numbers involve base 2 representation. So if in your mind you are clear with that, okay, that we are dealing with numbers that are involving base 2. Once this thing becomes clear in your mind, believe me, the questions will be super easy. The only thing that you need to be clear in your mind with is that, okay, we are dealing with some form of numbers that are in base 2. We are not used to dealing with these type of numbers. But yeah, the question is, so we have to deal with these type of numbers. So we have to be clear with that. We have to make some practice. We have to learn some new things, some basic properties. Once we are done with that, the thing will be exactly easy as it is with the numbers of base 10. It is that simple. So if this thing is clear in your mind, then again, just the same thing. You're solving problem that uses addition, multiplication, etc. That is not using actually the decimal representation, that is actually using a base 2 representation, right? So this is what actually the bit manipulation involves. The things will become more clear as we move forward. But before that, the one thing that should be clear in your mind is that we are talking of numbers that are not in its base 10 representation, that are in its binary representation. Like for example, if I say you what's the binary representation of 10, if I just tell you what's the binary representation of 10, just a minute. Okay. So how do we actually calculate this binary representation? If you all know, there is a very common method. We just divide it with 2, write the quotient over here and write the remainder over here. Then again, we divide it with 2. We write the quotient over here. We write the remainder over here. We again divide it with 2. We write the quotient over here and we write the remainder over here. So whatever number we got, that will become the binary representation of this number. So the binary representation of 10 is nothing but 1010 in base 2, right? So I hope Nora, we actually write it like this, 1010 from here, something like this. Is this thing clear? How do we actually represent numbers in their binary representation? Is this thing clear? All good? Okay. So let's now see, like as we know, when we talk of numbers in base 10, what have we actually learned when we were in class nursery or 1? What we have actually learned? We have learned how to add those numbers, how to subtract those numbers, how to multiply those numbers, how to divide those numbers, right? So the same thing when we are learning bit manipulation, that is we are dealing with numbers of base 2, we have to learn some operators that will actually help to solve the problems of bit manipulation. So now we are actually going to look over some of the operators, some of the very important operators, which you should definitely know if you are solving problems of bit manipulation. So starting with bitwise operator OR. So starting with bitwise operator OR. So what is OR operator? So just reading the statement, OR operator takes every corresponding bit of the two numbers and checks whether at least one of them is set. For example, if I tell you that I have a number A and the binary representation of this number A is 1010. Cool. Now if I take a number B and its binary representation is, let's suppose, 0, 0, 1, 1. And I tell you that do the OR between these two numbers. Just apply OR operator between these two numbers. This is what I tell you. Okay. So what will be the result? So as we already discussed that the OR operator gives you a set bit. Now you will question me, what do you actually mean by set bit? So set bit means that the value of the bit is 1, and similarly the unset bit means that the value of the bit is 0. So this is a common terminology that we use while we are solving problems of bit manipulation. A bit is set, this means that the value of the bit is 1. If the bit is unset, this means that the value of the bit is 0. Cool. So now if we are talking of OR operator, so what actually it does? If any of the bit is set, just repeating, if any of the bit is set, the resultant bit will be set. If any of the bit is set, then resultant bit is also set. So just following the same, let's apply the OR operator between these two numbers A and B. So just we will deal the problems bitwise. So just we will go bit by bit. So this is a number, we will just go bit by bit. So first of all, we will go from right to left. Okay. The first bit is this. In A it is 0. That is, in A it is not set, and in B it is set. So the resultant will be a set bit since there is at least one bit that is set, right? So the resultant bit will be 1. Similarly, when we are talking of this bit, so in A it is set, in B also it is set. So the resultant bit will also be set. Similarly, when we are talking of this bit, in A it is not set, in B as well it is not set. Now for the resultant bit to be set, at least one of the bits in A or B should be set. But it is not the case over here. So we will say that the resultant bit will be unset. So the value of the bit will be 0. Similarly, when we talk of this bit, in A it is set, in B it is not set. Since at least one of the bit is set, so the resultant bit will be 1. So this is what the result of OR operator is. So I hope this thing is clear. That if at least one of the bit is set, the resultant bit will be set, else it will not set. If I just take one more example, there can be multiple numbers as well. So let's suppose I am talking of A as 10110. I am talking of B as 11000. I am talking of C as 01000. Let's suppose I am talking of these three numbers and I want you to apply OR operator between these three numbers. Then say me what will be the result. Just tell me what will be the result. What do you guys think? Anyone who would like to answer this? Okay, so we have an answer with us. Someone saying 1110. Cool. We will see whether it is correct or not. Okay, so we have multiple answers now. 11110. Great. Okay, so let's check whether it is correct or not. So we are talking of first of all this bit. Okay, so since there is no bit that is set, and for the resultant bit to be set, we want at least one of the bit to be set. So the resultant bit over here will be unset. So the result is 0. Similarly, when we are talking of this bit, we have at least one bit that is set. So the resultant bit will also be set. Similarly, when we talk of this bit, we have at least one bit that is set. So the resultant bit will also be set. Similarly, when we talk of this bit, we have at least one bit that is set. There are two bits set, so we have at least one bit that is set. So the resultant bit will be set. Similarly, when we talk of this bit, we have at least one bit set. So the resultant bit will be set, and hence this will be our result. The question was that we were given three numbers A, B, and C, and we needed to apply OR operator between these three numbers. We basically wanted the result of A or B or C. This is what we wanted, and this will be our result. Is this thing clear to everyone? How we are actually applying OR operators in numbers? Any question till here? Any doubt? All clear, guys? Okay. So assuming it's all clear, let's move on to the next operator we have. So the next operator we have is bitwise operator, that is AND. So we talked of OR operator, so now let's talk of AND operator. So AND operator takes every corresponding bit of the number and checks whether both of them are set. Now this number does not want that at least one of the bit is set. This operator does not want that at least one of the bit is set. This operator wants that all the bits should be set. So if we are talking of, let's suppose, two numbers, if I let's suppose our A is 1010 and let's suppose our B is 0110, and I tell you to apply AND operator between them. So tell me what will be the result. So as we discussed, AND operator gives me a set bit only when all the bits are set. Otherwise, it will give me an unset bit. So following this, just go bit by bit. If I talk of this particular bit, are all the bits in this for this particular corresponding bit set? In A, it is not set. In B as well, it is not set. So we can say that the resulting bit will be an unset bit. That is, the value of the bit will be 0. Similarly, when I am talking of this bit, in A it is set, in B it is set as well. So for all the numbers we have, over here we have two numbers. So for we can say that for all the numbers we have, this particular bit is set in those corresponding numbers. Hence, the result of AND operator will be 1, that is a set bit. Similarly, when I am talking of this particular bit, in B it is set, but in A it is not set. So the resultant bit will be 0. Since all the bits are not set, hence resultant bits will be 0. And similarly, when I am talking of this particular bit, in A it is set, but in B it is not set. So the resultant bit will not be set, it will be an unset bit. So the result of A and B, this is actually how we represent an AND operator. So the result of A and B is equal to 0010, which can also be written as 10, right? You can just remove these leading zeros. Do you all get this? Anyone having doubt in this? So similarly, as we did for three numbers while we were discussing OR operator, the same thing can be applied for AND as well. You can do it with three numbers, four numbers, five numbers, any amount of numbers are allowed. Just see the bit. If all the bits are set, the resultant bit will be set. Else, the resultant bit will be unset. Is it clear, guys? Just a minute. Cool. Okay. So now let's talk of the next operator and very, very important operator, that is XOR operator. So let's see what the XOR operator does. So XOR operator takes every corresponding bit of the two numbers and checks whether exactly one of them is set. So over here, I am talking of two numbers. I will definitely extend this definition for multiple numbers as well. But for now, let's assume that we have two numbers. Okay, we have two numbers A and B. The numbers are A is 1100 and number B is 1010. Let's suppose we have these two numbers and I want to apply XOR operator between them. Okay. So now what will be the result? Now, as per the definition that we studied over here, the definition told us that if exactly one bit is set, then resultant bit will be set. Okay. So as you can see over here, if I just follow this definition and fill my answer. So if I am talking of this bit, do we have exactly one bit set? Do we have exactly one bit set? No, right? So the resultant bit will be an unset bit, that is 0. Over here, when we are talking of this bit, we have exactly one bit set, so the resultant bit will be 1. Similarly, over here, we have exactly one bit set, that is the bit is set in A and not set in B. So the resultant bit will again be 1. And when we are talking of this bit, we have two bits set. So we don't have exactly one bit set, so the resultant bit will be 0. So over here, if you have this number A as this and the number B as this, the result will be this. But over here we had two numbers. What if we have three numbers? What if we have four numbers? So extending the definition, the real definition is that the bit is set, or if I just correct this, the resultant bit is set if there are odd number of bits that are set. So what do we actually mean by this? If there are odd number of bits, if there are odd number of bits that are set, then the resultant bit will be set. Let's see. If we let's suppose say that the number A is 10110, number B is 01110, number C is 11110, number D is, let's suppose, 0100110. Okay, let's suppose we have these four numbers and I ask you that what's the result of A XOR B, XOR C, XOR D. This is my question. Okay, so what will be the result? So what I told, the resultant bit is set only if there are odd number of bits that are set, right? So let's apply this over here. If I am talking of this bit, tell me how many bits are actually set over here. How many bits are actually set over here? There are 0 bits that are set, right? And the value of 0, we consider it as an even number, right? So the resultant bit will be 0. The resultant bit will be 1 only if there are odd number of bits that are set. Okay. Similarly, when I am talking of this, let me just change the number a bit. Let me take this as 0. Okay. Now, when I am talking of this particular bit, so tell me how many bits are actually set. There are 4 bits that are actually set if I am not wrong. And the value 4 is even, right? So the resultant bit will be an unset bit, that is 0. Similarly, when I am talking of this particular bit, tell me how many bits are actually set. If I am not wrong, there are 3 bits that are actually set, right? And you know that the value 3 is odd. So now the resulting bit will be a set bit because there are odd number of bits that are set. Similarly, when I am talking of this particular bit, the number of bits that are set is 2, and we know that 2 is an even number. So the value, that is the resultant bit, will be an unset bit. Similarly, when I am talking of this particular bit, there are 2 bits that are set. So the resultant bit will again be an unset bit. So the result of A XOR B XOR C XOR D will be 00100. So this will be my answer. Is it clear for all of you? Like how we are actually deciding the resultant bit in case of XOR operator. So if any doubt exists in OR operator, AND operator, or XOR operator, then this is the right time to ask. Any doubt, guys? Clear? Great. Okay. So now before moving on to some more operators, what I'm going to do is I'm going to discuss some properties of bitwise operator that we have discussed till now. Okay, great. So let's discuss the properties. So the first property in line is that OR and XOR, all these three operators are both associative as well as commutative. So first of all, what do we actually mean by an associative? What do we actually mean by that? We know that a plus operator is associative, right? What do we actually mean by that? This means that A plus B plus C is equal to A plus B plus C, right? This is what do we mean by associative. Now, my claim is that all of the three operators that we have discussed till now, they all are associative. That is, OR operator is also associative, and is, as well as XOR is. So why I'm able to tell that? So tell me one thing. If I tell you that I have A over here, okay, I do its OR with B and I do its OR with C. And I do something like this, A or B or C in one operation. The other way that I do this is A or B or C. Okay. So if I just write them in their binary representation, do you all agree that if I, let's suppose, tell that my B is 1011, and if I say my C is 0100, and if I say my A is 1110, if I say you something like this, then do you all agree that at the end, after calculating this entire result, at the end, the thing that we are going to do is, if at least one of the bits in any of the corresponding bit position is set, the result of this entire operation will be a set bit, else it will be an unset bit. Do you all agree with me in this? My claim is that if I do the operation something like this, or if I do the operation something like this, at the end, the resultant will be that if any of the numbers have the bit set in the corresponding bit position, then that particular bit position will be a set bit, else it will be an unset bit. Think about it. Agree? So this is why I am able to say that my OR operator is associative, because at the end of the day, what we are doing is we are placing all these numbers one by one. And if at least one of the bit is set, we are saying that the resultant bit is set, else the resultant bit is unset. Right? Similarly, I can say the things for AND operator as well. I can say it for XOR operator as well. Because that is what we are going to do. We are going to place these numbers A, B, and C in line, and just we are going to see, and just we are going to apply the properties of AND and XOR and going to calculate our result. It does not matter whether we first of all calculated A and B and then we are doing AND with C, or first of all we have calculated B and C and then we are doing AND with A. It will never matter. Right? Any doubt, guys? So is this property clear that both OR, that all of these operators OR and XOR are associative? Similarly, we can say that they are commutative as well. What do we actually mean by commutative? That let's suppose A plus B, if we say that plus operator is a commutative, this means that A plus B is equal to B plus A, right? Similarly, we can say that these operators that we discussed are commutative as well, because it does not matter that whether, if you, let's suppose your A is 1010 and your B is 0111. So it does not matter whether you place this B below or you place this B above, right? If you are calculating OR, you can calculate like this as well, or you can calculate like this as well. It will result you the same result, right? It does not matter where the bit is set. When I told you that OR operator wants at least one of the bit to be set, had I told that it should be set at this particular position, it should be set at this particular position, that was not the claim, right? The claim was that at least one of the bits should be set. So it does not matter whether you write B above or you write B below, the result will be same any day. What if we have different operator? Then we can't say that. Then we can't say that, Ram. We can't say that A plus A and B or C will be equal to A or B and C. This is wrong. We can't say this. We are talking only of a single operator at a time, and then we are saying that they are commutative and associative. Just relate this to the decimal representation. As we told that A plus B plus C is equal to A plus B plus C, right? We can always say this when we are talking of base 10 numbers, right? So over here we can't say that A plus B multiplied by C will be equal to A plus B multiplied by C, right? We can't say this. The same goes with these operators or and or as well. Is it clear? Is it clear? Just all good, guys? Yes, great. So now let's move on to the next operator we have, next property we have, that is A XOR 0 is equal to A. So just try to think a bit. Isn't it obvious? Just try to think. Isn't it obvious? Try to think a bit. If I tell you that I have a number A, okay, and the number is anything 101101, and I tell you to apply XOR operator with 0. So how do we actually represent 0 in base 2? You can just write 0 something like this, right? And I tell you that apply the XOR operator. Tell me what will be the result. If the bit in A is 1, then tell me what will be the resultant bit. Is the video lagging? Is it okay now? It's stuck. I don't know what's the reason. Let me check. Let me check. Is it okay now? Are you guys able to see my screen? Just confirm. Is it okay now? Yeah, good. So, okay, great. So now if I tell you that let's suppose a bit is set in A, okay? And if a bit is set in A and I am doing the XOR with 0, tell me what will be the resultant bit. Tell me what will be the resultant bit. It will be 1, right? Because we should have exactly odd number of bits that are set. For the resultant bit to be set, and if we are applying XOR operator, we know that exactly odd number of bits should be set. And since we are doing the XOR with 0, so we know that if the number has a set bit, then resultant bit will definitely be set. Right? Is it lagging again? I don't know what's the issue. Just give me a minute. Let me set this. Are you guys able to see my screen now? Is my screen visible? Yep. Okay. Great. So if I'm talking of that, if the bit is set in A and I'm doing the XOR with 0, so the resultant bit will be a set bit. Do you all agree with me in this? Do you all agree with me in this? Similarly, if I tell you that the bit is not set in A, so can you guys tell me that what will be the resultant bit? If a bit is not set in A, then do you guys agree that the resultant bit will also be not set? Because we are doing the XOR with 0, so there will be an even number, that is 0 bits that are exactly set. So the resultant bit will also be 0. So if the bit is set in A, it will be set in result. If the bit is not set in A, it will not be set in result. So we can definitely say that A XOR 0 is exactly equal to A. Do you guys get this property? That A XOR 0 is exactly equal to A, and this is very important property. Like, this is used many a times. All cool? Should we move on to the next property? Yes, great. So the next property is that A XOR A is exactly equal to 0. That is, if we are doing XOR between two numbers that are exactly same, or if I say this, that if I do the XOR of a number with itself, then the resultant will be 0. Can you guys tell me that why such thing is happening? Why if I doing the XOR of a number with itself, the resultant is 0? Okay, so 0 XOR 0 is equal to 0 because I told you that if I am doing the XOR operator, if I am applying XOR operator, then for the resulting bit to be set, there should be exactly odd number of bits that are set. Now, since over here there is 0 bit data set, right? No bits are set, that is 0 bits are set, and we consider 0 as even, so the resultant bit will be unset. Okay, great. So now can you all tell me that why A XOR A is equal to 0? That is if I do the XOR of a number with itself, why the result is 0? So let's understand this with the help of an example. Let's suppose A is 101101 and I am doing the XOR with 101101. So do you guys agree that if the bit was set in A, then at the end you will have exactly two bits that are set, and if two bits are set, we know that the resultant bit is 0. That is, if even number of bits are set, we know that the resultant bit is 0. Similarly, if the bit is not set in A, then you will end up having 0 bits that are set, and again 0 is considered as an even number, so the resultant bit will be 0. By this, we can say that if we do the XOR of a number with itself, the resultant will always be 0. Is it clear? You don't need to learn these properties. As you solve more and more questions, you will get familiar with these. But again, repeating, these are very, very important properties, and you are going to use these properties in many questions moving forward. Cool. Should we move on to the next property? So this is done. Okay. So the next property is again very, very important. That A XOR B is equal to C. If A XOR B is equal to C, then you can say that A XOR C is equal to B. Let me write it over here. If A XOR B is equal to C, this implies that A XOR C is equal to B, or you can write it something like this as well, that B XOR C is equal to A. You can always write something like this. Is the screen visible, guys? Like, is there a lag? C can be A or B. What do you mean by that, Ram? C can be A or B. It's fine, right? So if so A XOR B is equal to C, this implies that A XOR C is equal to B, or you can even write it like B XOR C is equal to A. Okay. So let's understand this with the help of an example. Let's suppose A is 10110. Yeah, C is different. C is different. Okay. And let's suppose B is 10100. And let's calculate A XOR B. So A XOR B will be 0 1 0 0 0. Okay. So now let's name this as C. Now, as I told, let's calculate A XOR C. So the A is 10110, C is 0 0 0 1 0. And now if I simply calculate A XOR C, the result will be 0 0 1 0 1, which is exactly equal to B. So we can say that if you are able to write that A or B is equal to C, then at any point of time, what you can do is you can take this C in the left hand side and bring any of these A and B towards the right. So you can always write that C XOR B is equal to A. You can always write A XOR C is equal to B as well. Similarly, if let's suppose we were having four numbers, if I would have written A XOR B XOR C is equal to D, then you can definitely write it something like this, that you can bring this D over here and send any of these three variables towards the right. So you can always write A XOR D XOR C is equal to B, and you can send any of these A and C as well, and it always works. So is this thing clear? This is a very important property and you all should know this. Yeah, right. Right. Great. Cool. So let's move on to our next property, that A XOR B XOR B is equal to A. Do I need to discuss this? First of all, tell me. Do I need to discuss this? Can I derive this from any of the above properties? Can I? So it's written A XOR B is equal to A. So this is right? Because when we XOR two numbers that are equal, that if I do XOR between two numbers that are same, so the result is 0, right? So we will get a XOR 0. And we know that if we do the XOR of a number with 0, the result is the number itself. So I will get a. So this thing is clear, right? Don't treat it as a property. So you can always derive this from any of the above properties. Right, right, right. Great. Now the next property. And let me tell you that next property that we are going to discuss is again very, very important. And this is something that are used in many questions, not only in bit manipulation problems, but in many, many problems. So this is again a very important property. The property is that A and B is lesser than equal to minimum of A comma B. A and B is less than equal to minimum of A comma B. That is, if I just tell this in theoretical words, that if we do AND between two numbers, the resultant will be lesser than equal to the minimum of two numbers. And let me tell you why. If I let's suppose tell you that my number A is 10110 and my number B is 01101. Tell me one thing. If I want the resultant bit to be set, what is the requirement? If my resultant bit is set, then what is the requirement? The requirement is that both of the numbers should have the bit set. Agree? The requirement is that both of the numbers should have that bit set. Right? So if both of the numbers are not having the bit set, so the resultant will be 0, right? As in this case, the resultant is 0. In this case, both of the bits were set, so the resultant is 1. In this case, it is 0. In this case, it is 0. Now, what I am pretty sure is that the resultant will always be lesser than equal to minimum of A comma B. Because when I am talking of resultant, so resultant have only those bits set that are set both in both of these numbers, A and B. Resultant will have only those bits set that are set both in A and B. But it may not have some bits set that was set in either A or B. Do you guys agree? The resultant may not have some set bits that was set in either A or B, as in case of this. So what I am sure of, that it will always be lesser than or equal to minimum of A comma B. The best case scenario is that it becomes equal to one of the numbers, but it can never exceed those numbers. Because when I am telling that the resultant will exceed a number, what does I mean by that? By that I mean that the resultant has some bit set that is not set in that particular number. If I name this as C, and if I tell you that C is greater than A, what do I actually mean by this? By this I mean that C has some bit set that is not set in A. But tell me, is it ever possible that C will have some bit set that is not set in A? Is it ever possible? The answer is a big no, right? It is not possible. Because C has only those bits set that are set in both A and B. So that is the explanation of why A and B is lesser than equal to minimum of A comma B. Cool. So this is a very, very important property. So you can always write this like this. You can extend it like this as well. That A and B and C is lesser than equal to minimum of A comma B comma C. You can write any amount of numbers and you can be pretty sure of that the AND operator result will not exceed the minimum of the numbers. Cool. Okay. So let's move on to the next property. The next property is that A or B is greater than equal to maximum of A comma B. The property is A or B is greater than equal to maximum of A comma B. So again, the explanation remains the same. Okay. The explanation is that if I tell that A or B is equal to C, so C will have set bits if either of A or B have that particular bit set. Right? So do you guys agree? Like let's assume that B is the maximum number when we are comparing it with A. Okay, B is greater than A. Let's suppose B is greater than A. Then first of all, tell me, do you guys agree that all bits that are set in B will be set in C? That is the result. Do you guys agree with this? That all bits that are set in B will be definitely set in C. Now let's assume number A was 0110 and number B was 1001. So I know that in my C, all the bits that are set in B will be definitely set. Additionally, it may occur that the bits that are not set in B, they are as well set in C. For example, these bits were not set in B, but they will be set in C, that is the result of A or B, because they were set in A. So what I can say is that A or B will always be greater than equal to maximum of A comma B. Is it clear for everyone? Yeah, true. Is it clear for everyone? Any one of you having doubt in this? Clear? Great. So this is done. Now the next property. So A or B plus A and B will be equal to A plus B. Now again, this is the property that I kept. You will not see this property everywhere, but I kept this property because I just remember solving one interactive problem of about 1700 or 1800 rated that was easily solvable if you know this property. It was solvable in minutes if you know this property. So the property is that A or B plus A and B will be equal to A plus B. This is the property. Now why this is true? Can anyone say why will this work? Why will this work? This is because if I let's suppose tell you that a bit is set in A and it is set in B as well. Okay. If a bit is set in A and it is set in B as well. So when you are writing A plus B, so what you're going to do? You're going to add two ones, right? You're going to add two ones. Similarly, if you do these operations, first of all, you calculate A or B. Then do you guys agree that A or B will be equal to 1 and A and B will also be equal to 1? So if I just calculate A or B plus A and B, then we are going to do the same thing. We are going to add two ones only, right? Yeah, Lucky, that actually not the intuition because mean or max is actually does not the is not the intuition behind it here. But you can always think of something like this, that you can always take the all possible options you have. What are the options you have? The options are that a bit is set in A and a bit is set in B. So if you are writing A plus B, so what you're going to do? You're going to add two ones. Similarly, if you calculate A or B, that will be 1. If you calculate A and B, that will be 1. So when you add these two numbers, you will be adding 1 and 1 only. Similarly, let's suppose both of the bits were 0. In A it was 0, in B it was 0. Okay. So what you're going to do when you're going to do A plus B? You're going to add 0 and 0. So let's see whether you will do the same thing over here in LHS as well or not. So first of all, you calculate A or B. So that particular bit will be 0. You calculate A and B. That particular bit will again be 0. So when you are going to add A or B and A and B, you are going to add 0 and 0. Similarly, it can be that the bit is set in any one of the numbers. So let's suppose it is set in A and it is not set in B. So when you are going to do A plus B, you are going to add 1 and 0. And when you are going to calculate via LHS, so calculate A or B, it will be 1. Calculate A and B, it will be 0. So when you add A or B plus A and B, you are going to add 1 and 0 only. So the result will never differ. So we can say that A or B plus A and B will always be equal to A plus B. Clear? Any doubt regarding this property? Any doubt, guys? Should we move forward? Great. Okay. So the next property is that A and 1 is 1 if A is odd, else it is 0. So the statement is that A and 1 is equal to 1 only when A is odd. So before discussing this property, I want to discuss one another important thing. The thing is that if I tell you that a number A in its binary representation is, let's suppose, 10110, it is in base 2. Can anyone say me its decimal representation? Can anyone say me its decimal representation? How do we actually calculate its decimal representation? How do we actually do that? So just tell me, do you all agree with me in this or not? What we do is, we first of all take the rightmost bit, 0, its value, multiply it with 2 power 0. Then we take this bit 1, multiply it with 2 power 1. Then we take this particular bit, multiply it with 2 power 2. Then we take this particular bit, multiply it with 2 power 3. Then we take this particular bit, multiply it with 2 power 4. And then sum these results, and whatever is the result, that will be our number. Do you guys agree with me in this? It will be basically 0 plus 2 plus 4 plus 0 plus 60, which will be equal to 22. Do you guys agree with me in this? Yes? So tell me one thing. If I am telling that this binary representation is a binary representation of an odd number. Okay, if I am telling you that this binary representation is the binary representation of an odd number, so what is the requirement for that? Is there any requirement that that particular bit should be set or that particular bit should be unset? Is there any such requirement over here? The answer is yes. Because if you just observe these terms, this term will always be even no matter what the bit value is, because it is multiplied with 2 power 1. Similarly, this term will always be even no matter what the particular bit is, because it is multiplied with 2 square. Similarly, all the forward moving terms will always be even. The only term that can make this entire result odd, the only term that can make this entire result odd is the first term. Do you guys agree? Because it is multiplied with 2 power 0, that is 1. So if that particular bit is 1, the entire result will be an odd number, because even plus even plus even plus one odd number will always be an odd number. And if this particular bit is 0, the resultant will be an even number. Do you guys agree? Because all other terms are even. The only term that has the possibility of being odd is this first term. Then can I say that if I am saying that a number is odd, then whatever is a number, whatever it is, its binary representation, it does not matter. The last bit should always be 1. Do you guys agree with me in this? The last bit should always be 1. So this is the basic requirement for the number to be an odd number. Now let's come to the property. The property was that a and 1, I am doing AND of a with the number that is 1, and it will be 1 only when number is odd. That is, only when a is odd, then only this will come into 1, otherwise it will come down to 0. And the reason is that if I am having any number a, whatever is its number over here, it does not matter. If its last bit is 1, what I'm going to do? I'm going to do AND with 1. If I just write a binary representation of 1, it is like this, right? This is the binary representation of 1. What I know is that since all these bits are 0, it does not matter what it is in A, it will always come down to 0. The only possibility of a bit that can be set is the rightmost bit, that is the least significant bit, and it will be set only when it is set in the number. If it is not set in the number, it will be an unset bit. If it is set in the number, it will be a set bit. And what we know, that it is set in the number only when the number is odd. So only when the number is odd, the resultant will be 1. Otherwise, the resultant will be 0. Confusing here from the term odd, its context has changed. No, first of all, I was talking that what is the requirement for the number to be odd? The requirement is that in its binary representation, the last bit should be 1. Now coming down to the property, I told that if I do the AND of the number with 1, the resultant is 1 only when the number is odd, else the resultant will be 0. Now the reason is that if I do AND with 1, so this is the binary representation of 1. I know that all these bits are 0, so the resultant bits will also be 0 for all these bits. The only bit that can be set is the least significant bit. And when it will be set? It is set in 1. So it will be set only when this particular bit is set in the number itself. And it will be set in number. Now it will be set in number only when the number is odd. So a and 1 will be equal to 1 only when the number is odd, else it will be 0. So many of you would have seen the code of coders, many coders. They don't write to check whether the number is even or not, something like this. They don't write it like a modulo 2 equals 1 to check whether the number is odd or not. They simply write if a and 1. Then the code for a equals to odd, else the code for a equals to even, right? Because this bitwise operators are somewhat faster as compared to this modulo operator. Is it clear? Should we move on to the next property? All clear, guys? Okay. So let's move on to the next property. The next property is that A and A minus 1 is 0 if A is power of 2. So let me discuss. So if A is power of 2, then let me tell you how the number will look in its binary representation. So number will look something like this. One bit will be set and all other bits will be 0. If you look to some number in its binary representation and it is looking something like this, then we can definitely say that this is some number which is power of 2. Right? It's like this 100 base 2. This is nothing but binary representation of 4. 10 base 2. This is nothing but binary representation of 2. 1000 base 2 is nothing but binary representation of 8. Similarly, 10000. This is nothing but binary representation of 60. Something like this. This is nothing but binary representation of 32. So if you are talking of a number which is the power of 2 and its binary representation, then it will always look something like this. That a number will be 1, then there will be one set bit and all other bits will be 0. Do you all get this? Do you all get this? Yes? Now let's come to the property. The property is that if I am calculating A and A minus 1, the resultant will be 0. And let me tell you why. And this is when A is power of 2. Okay. This is because if I'm talking of A which is power of 2, so its binary representation will look something like this, right? Now let's calculate A minus 1. So for that, what I need to do, I need to subtract 1 from here. So just observe what will happen. It will take carry from here, 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 and it will take carry from here. So it will become 1, 0, that is 2, and 2 minus 1 is equal to 1. Now when this took carry from here, it became 2, but it gave 1 to this, so it is left out with 1. So 1, 1, 1, 1, and it since it gave 1, so it will become 0. So this is what A minus 1 is. Now if I simply do A and A minus 1, so let's see what we are actually doing. This is my A, this is my A minus 1. Can I say that if I just apply AND operator between them, the resultant will be 0? Do you guys agree? So this is why we say that if A is power of 2 and we calculate A and A minus 1, the resultant will be 0. Okay. So I hope this is clear. Cool. So we are done discussing with some basic properties that are required. So now we are going to discuss two more operators that are again very important. Some miscellaneous operators. They are bitwise left shift operators and bitwise right shift operators. So let's first of all discuss bitwise left shift operator. So what do we actually mean by this? So if I write A left shift B, so what it will do is it will add B zeros at the end of A. It will add B zeros at the end of A. And what happens when we do this? The resultant will be A multiplied by 2 power B. Like as I say you in decimal representation, if I say you that I have a number 243, okay, and if I say you that I add two zeros at the end of this, do you guys agree that this is nothing but 2403 multiplied by 10 square? Do you guys agree that if I add two zeros at the end, the number will become the number multiplied by 10 square? Similarly, if I add b zeros at the end of some number a in its binary representation, the number will become a multiplied by 2 power b. Like for example, if I say you that I have a number, let's suppose 101, this is the binary representation of 5, and I add two numbers at the end of this. So what I do is I just add two numbers at the two zeros at the end of this, something like this. So this was the binary representation of 5. You guys can check. This will be the binary representation of 5 multiplied by 2 square, that is 20. We added two zeros at the end, so 2 square will be multiplied to this number and the resultant will be 20. This is what actually we mean by bitwise left operator, and this is the symbol we actually use. So a left shift b is nothing but a multiplied by 2 power b. Do you guys get this? What do we actually mean by bitwise left shift operator? Any confusion in this? Any confusion, guys? Great. Similarly, we have a right shift operator as well. So a right shift b means remove last b bits and shift the remaining bits towards the right. Like for example, let's suppose I tell you that I am calculating 10 left shift 2. Okay. So what is the binary representation of 10? It is 1010, right? And if I am calculating left shift 2, so what I will do is I will remove last two bits. So last two bits will go into dump. I will just remove last two bits and I will shift the remaining bits. If I do that, the resultant will be 0010, which is nothing but binary representation of 2. So right shift operator basically means that if I am calculating a right shift b, so the resultant will be a divided by 2 power b. And this is actually the integer division. As we do in while writing the code, integer division, this is what it is. Like for example, I did 10 left shift 2. So 10 left shift 2 basically means 10 divided by 2 power 2, which is equal to 10 divided by 4, which is equal to 2. And you all can see that 2 is the result. So this is what we mean by left shift operators and right shift operators. Are these two operators clear to everyone? Anyone having any doubt? Is this thing clear to everyone? Clear? Great. So now we are going to move to the last topic of discussion for today, which is the most important of all. So whatever we have learned till now, it was actually a build-up for this topic. And let me tell you one thing, that if you are thinking of solving questions of bit manipulation, this is something that should be super clear. If this thing is not clear, then I can guarantee that you can't solve even a single question of bit manipulation. This is like for calculus, you all should know trigonometry and all. And for trigonometry, you all should know the value of sine angles, cosine angles, like sine 30, cos 60, right? We all should know that even in our dreams. So this is something what it is related to bit manipulation. You all should be clear with these four things, what we are going to discuss next. If this thing is clear, then you can think of solving questions of bit manipulation. And believe me, these are super easy. Like, I am going to take this as a topic for now, but when I learn this, it just goes with the question. So just apply a bit of brain and these things will come clearly. And you don't need to learn this. The more and more you solve questions, the more and more these things will become clear. Whatever is the prerequisite that we have already discussed in our class till now. Okay, so let's start with this. My first question is that I want you to set the kth bit. What do I actually mean by this? Let's suppose I tell you I have a number A and my number A is 1101011. Okay, this is my number and I want to set the fourth bit. So what I'm assuming is I am assuming zero based indexing. So I am saying that this is my bit 0, this is my bit 1, this is my bit 2, this is my bit 3, this is my bit 4, this is my bit 5, and this is my bit 6. So what I want is, I want to set the fourth bit in this particular number. Now the question is, how will I do this? Do any one of you have any idea how we can do this? How we can do this? I want to set the fourth bit in my number. Any idea, guys? How we can do this? Left shift 2. No, it will not work. If we do left shift 2, it will add 1 0 at the end, right? But we want to make the fourth bit set. First of all, tell me what will be the result. Do you guys agree that the result will be 1 1 1 1 0 1 1? That is, all the bits will remain as they were initially. Only the fourth bit will become set. Right? Or operation with 2 power 4. Right. 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 Yeah. Right, Bharat. Anyone else who would like to get some answers? See, let's suppose I tell you my number A given is 110101, right? And what I want that all the resulting bits should be set. All the resultant bits should be set. Or all the resultant bits should be as it is, and this particular bit should be set. This is what I want, right? And let's suppose I tell you that I am going to apply OR operator over here. Okay, you will get this why we are applying OR operator, what is the number we are going to choose. You all will get all the things. First of all, tell me why OR operator. You will get this. Just give me a minute. Okay. So with what number? Just tell me with what number should we do OR operation that we get this particular number? With what number over here should we do OR operation such that we get this particular number? So your answer can be that, okay, let's suppose this is the number. This is the number. I can choose this number and I can do OR with this. I will get this number. So now I will say that, okay, you are correct. You are not wrong. Because if you choose this number, do OR with this particular number A, you will get this resultant answer which you want. Similarly, so this is one choice. Let's keep it over here. We have one choice, 1111 We can choose this number. Let's choose some other number as well. Let's suppose I tell you that I choose this particular number. I choose this particular number. Now again, if I OR with this particular number, I will get my resultant number. If I do OR with 1111 I can get this particular number again, right? So there are multiple options. But just imagine one thing, what I have given to you. I have given to you this number A and I have told you to set the fourth bit. And you need to construct this number by your own. Do you guys agree that you need to construct this answer by your own? You need to construct this number by your own. So this is not an easy number to construct. But if I tell you that I am doing OR with this particular number, 1101, 011. This was the number A. And I tell you that I am going to do OR with this particular number. First of all, tell me, will I get the desired result? Will I get the desired result? Do you guys agree that the result will be 1111, which was actually desired? And now this number construction is super easy. If you just observe, this is nothing but 2 power 4. So if I simply write 1 left shift 4, so what it will do? It will just calculate 1 multiplied by 2 power 4, which is nothing but 2 power 4, right? So if I just do something like this, A or 1 left shift 4, I will have the fourth bit set in my number. Because in this number 1 left shift 4, all the remaining bits will be 0. So in the resultant they will be set only when it is set in the number. If it is not set in the number, in the resultant it will never be set. But we want a bit to be set no matter whether it is set in the number or not, because we want to set the fourth bit. So for that, what we did, in this particular number, we kept our fourth bit set. So as a result, in the resultant number, this particular bit will be set, and hence we will get the desired result. So now all this intuition should be clear that why we are using the OR operator and why this particular number. Because this particular number is easy to construct, and hence we are using this particular number. So if I want to set the kth bit, if let's suppose the number is A, so if I simply write A or 1 left shift K, then the kth bit will be set. Over here we are assuming the value K as 0 based indexing. So if I just write A or 1 left shift K, the kth bit will be set. Is it clear? Any doubt till now? Is it clear, guys? Yes? Okay. So now let's move on to the next one. Check if kth bit is set or not. I want to check whether kth bit is set or no. How we can do this? Try to give a thought on this. How can we do this to check if the kth bit is set or not? Any idea? How we can do this? Is the problem statement clear? The problem is that I want to check whether kth bit is set or not. Like for example, let's suppose the number A is 101101. Okay, and I let's suppose want to check that whether the third bit is set or not. So over here the third bit is set, so I will simply return true, otherwise I would return false. Okay, So we have an answer, Rohan. Yeah, great. Anyone else who would like to answer this? Try to think, because see, bit manipulation is all about thinking a bit. It is not at all tough. Even I had fear from bit manipulation when I started with programming. I used to leave questions of bit manipulation when it used to come in contests. But day by day, when I kept on practicing, when I visualized the things a bit, the things become clear. Because all of us have already studied about numbers. We have studied of the numbers in base 10, right? So we don't fear from numbers. Just the little thing is that the numbers over here are in base 2. So it's a bit a new thing for us, and hence the fear develops. But just imagine, it's only a new thing. It's not a tougher thing. And it is very, very much related to the numbers in base 10 that we have already learned so far from class 1 and all. Right? So it is again very easy topic, but the only thing is you have to visualize a bit, you have to understand the things a bit. Because it is a new thing that you are learning. So every time you learn a new thing, you have to give a bit of effort, right? So now coming to the question, we want to check that whether the kth bit is set or not. So how we can do this? So tell me one thing. If I just apply and with, I want to check whether this particular bit is set or not. Okay. If I simply apply and with this number, can someone tell me what will be the result? If I simply apply AND operation with this particular number, can someone say me what will be the result? Do you guys agree that result will be this? Right? So I wanted to check whether this particular bit is set or not. Let's suppose A was this. And I wanted to check whether third bit is set or not. And I applied AND operation with this particular number. Now can you guys tell me what will be the result? This is actually 8, Ram. Bharat, sorry. This is actually 8, not 16. Okay. So tell me what will be the result if I just apply AND operation of, let's suppose the number E was this, and I apply AND operation with this. Do you guys agree that this will be 0? So are you guys able to see one thing? If I apply AND operation with an of number A with some number that have only the kth bit set, I want to check whether the kth bit is set or not. So that have only kth bit set and all the other bits are unset. So in my result, what I'm pretty sure is that all other bits that are not the kth bit, all other bits other than the kth bit will definitely be unset, because not all bits will be set for those bits. And for the kth bit, the resultant bit will be set if it was set in the number, and the resultant bit will be unset if it was not set in the number. So, if the kth bit was not set in the number, the result will be exactly 0. And if it was set in the number, the result will be non-zero. Just don't get confused, the result will not be 1. So don't write that A and 1 left shift K is equals 1. I have seen students making this mistake. So it will not be 1, only the result will be non-zero. Okay, the result will be non-zero. So if the result is 0, what we can say? That the kth bit is not set. And if the result is non-zero, then we can say that the kth bit is set. And this is how you can check that whether the kth bit in the number is set or not. And again, why AND operator and why this number? This is because AND operator will help me to get all these bits 0 if it is 0 in the number, if it is anything in the number, and for the k, and choosing this number because it is easy to form. We can easily form this number by just doing 1 left shift K and we will get this number. So you can easily check that whether the kth bit in the number is set or not by simply doing A and 1 left shift K. So if the result is non-zero, this means that the kth bit is set. If the result is 0, this means that the kth bit is not set. Is this thing clear? Any doubt over here? All clear, guys? Any doubt? You can just let me know. Yeah. Clear? Great. Now the next point is toggle the kth bit. Do you all understand what do we mean by toggle? Many of you would have heard this term during your web development if any one of you would have done this. Toggle. Toggle means change the current state. This means that if the current bit is 0, change it to 1. If the current bit is 1, change it to 0. On off, yeah, right. On off. You can imagine something like that. Yeah, you can say it as flipping, you can say it as on off. So basically toggle. Change the current state. If it is 0, change it to 1. If it is 1, change it to 0. Okay. So now what I want? I want that if I let's suppose give you a number 1010110, and if I let's suppose ask you that toggle the fourth bit. Toggle the fourth bit, and I want you to tell the result. So first of all, tell me what will be the result. This is my fourth bit, right? If I'm assuming zero-based indexing, this is my fourth bit. Then say me what will be the result. All other bits will remain as they are. Only the fourth bit will get toggled. So I will get this as my answer. Do you guys agree that this will be my answer? Is this thing clear that this will be my answer? Anyone having doubt in this? Anyone having doubt in this that this will be my answer? No, right? I just toggled the fourth bit and all other bits remained as they were. No? Great. So how we can actually do this? So before doing this, you need to know the important property of XOR. See, if I am having any bit, let's suppose the value of the bit is 1. It is a set bit, okay? And if I do XOR with 0, can anyone tell me what will be the result over here? What will be the result? If I'm not wrong, it will be 1, right? Because odd number of bits are set. So the result will be 1. Similarly, if let's suppose the bit was 0 and I XOR with 0 again. So again, what will be the result? The result will be 0, right? Because there are even number of bits that are set. So if even number of bits that are set, then the resultant will be unset bit. If there are odd number of bits that are set, the resultant bit will be a set bit. Similarly, if I tell you that a bit is 1 and I XOR with 1, so what will be the answer? If the bit was 1 and I XOR with 1, what will be the answer? The answer will be 0, right? Similarly, if the bit was 0 and I XOR it with 1, what will be the answer? The answer will be 1. So are you guys able to or observe one thing? Are you guys able to observe one thing? What is actually happening? So the observation from here is 0 XOR with, sorry, 1 toggled the bit, and XOR with 0 did not change the bit. Do you guys agree with me in this? That if I am doing XOR with 0, the bits remained as they were. When I did XOR with 1, the bits toggled. That is, if it was 1, it changed to 0. When it was 0, it changed to 1. Applying this operation in this thing that we need to change this kth bit, right? And we want all other bits with 0. Then do you guys agree? If I simply XOR this with this particular number, if I simply XOR this number A with this particular number, then only this particular bit will be toggled and all other bits will remain as it is. So this is how, and this is nothing but one left shift K, where we wanted to toggle the kth bit. So this is how actually we can toggle the kth bit in the number. This is because we know that when we have 0 and we are doing the XOR, the bits will remain as they are. And if we have 1 and we are doing XOR, the bits will get toggled. So applying this property of XOR, we can easily toggle the kth bit in our number. Is this thing clear for everyone? Is this thing clear? Anyone having doubt in this? How we will toggle the kth bit? So the thing is that if we have the number A with us, if we simply do A XOR 1 left shift K, the kth bit will get toggled. And this is how actually we can do this. All clear? Anyone having doubt in this? Should I repeat this? Okay. So let's move on to the last one. That is, we want to unset the kth bit. Okay. So what do we mean by this? Let's suppose I have the number A as 1011010 and I want to unset the kth bit. Let's suppose I want to unset this particular bit. Then first of all, tell me what will be the result. Do you guys agree that result will be this? The thing is that I want to unset the kth bit. Over here, I assume that the value of k is, let's suppose, 4. I want to unset the fourth bit. So this will be the result. Do you guys agree? Now the question is how we can do this. How we can do this? How we can unset the kth bit? Tell me, anyone having any idea in this? How we can actually do this? So if you just observe what we are actually doing, we are keeping all the bits as it is, and we are simply toggling that kth bit. Do you guys agree? We are keeping all the bits as they were and we are only toggling this kth bit. Now the problem is we can't always just write like A and A XOR 1 left shift K. This will not always work. Let me tell you what's the reason. The reason is it may be that I give you A something like this, where the kth bit is already unset, and I want you to unset the kth bit. This means that the resultant answer will not change. It will be as it is 1001010. So if I just toggle the kth bit, then the 0 will change into 1, which is something that I don't want. So how I can actually do this? The thing is clear that I want to toggle the kth bit. But when? So what I want to do? If I want to unset the kth bit, then do you guys agree that what I need to do? If the kth bit is set, then toggle the kth bit. Do you guys agree that if we apply this, then I will be able to succeed or I will be succeeding unset the kth bit? Yes. If it is set, then only toggle. Right? If it is set, then toggle the kth bit. This is what we actually want. Now, this is something that we have already done. We have learned how we can check if the kth bit is set or not. We have learned how we can toggle the kth bit. We know both of these things. So applying both of these things, we can unset the kth bit. The code will be that if A and 1 left shift K, that is the kth bit is set, in that case, toggle the kth bit. So change A is equal to A XOR 1 left shift K. If you simply do this, you will able to succeed in unsetting the kth bit. This is how you can unset the kth bit. Is this thing clear to everyone? So if kth bit is set, then toggle the kth bit. This is what actually we want. So I hope all of these things are clear, how we can set the kth bit, how we can check that whether the kth bit is set or not, how we can toggle the kth bit, or how we can unset the kth bit. So what are the things that we learned today? We learned that what are the OR operator, AND operator, XOR operator. Then we learned some very important properties. After moving on from properties, we learned some miscellaneous operators, that is left shift and right shift operator. Once we were done with that, we learned some very important way of manipulating bits, that is to check whether the kth bit is set or not, check if how we can set the kth bit, how we can toggle the kth bit, or how we can unset the kth bit. So these were the things that we discussed. I hope it was clear. So if any doubt exists after this, you can let me know. So this is all what we had for discussion for today. So if any one of you think that this way of teaching suits your way of learning as well, then you can definitely choose to join TLE. So this was a demo class for level 2, and this is how we actually run over there. We even have daily practice problems as well. So after every class, you will get daily practice problems, which will be based on the topics we discussed in the class, and that will be super helpful, I think. Some problem set based on this. So now what you can do is you can go to code forces and apply the tags bit manipulation, and you will get some really good problems. You can apply your rating range and you can solve problems from there. So this is not the entire bit manipulation that I needed to discuss, but again, this is a demo class and introductory class. So this is the only thing that we can discuss in the span of these 2 hours. But this is not the only thing that we discuss in bit manipulation. There are a lot more topics to learn and there are a lot more content in this. But again, when I talk of starting with the things, then this is the way you actually start. For that, Rohan, what you can do, you can go to problem set in code forces. Over there, you can apply like rating range. There is a rating range box. You can select there and you can apply tags as well. You will get that. Uh, where lucky? Where you want me ever solve problems there? Which problems are you talking, Lucky? In code forces? Are you talking in code forces? Okay, okay. Any other doubt, guys? Or should I end with the session? So hope to see you all in TLE. So great, great, great. CP31 sheet is again a very excellent sheet by Priyansh. So you all can refer from there as well. Yes, CodeChef weekly contests are good. Mainly for mathematic purpose and greedy solution questions, I would say CodeChef is one of the best platform you have for mathematical and greedy questions. Great, Rohan, great. Okay, thank you guys. Thanks for joining. Bye bye.